Hi everyone, it's Jenna. Welcome to Miss Maths 1. Today we have a request for prime bases, a topic which you learn in grade 9 and it follows through till grade 12. Okay, so first of all, let's break up what this means. So to start off, we need to understand what a prime number is. And the definition for a prime number is a number with only two factors, namely 1 and itself. For example, if I was to look at the number 3. 3 is an example of a prime number because the numbers that can fit into 3 are 1 and 3. Okay, whereas a number like 4 is not a prime number because the factors of 4 are 1, 2 and 4. And clearly you can see that there are more than two factors. So 4 is composite whereas 3 is prime. So for this section we are going to be looking at prime numbers. Now, the second word we've got over here, bases. Now, specifically when we are dealing with these types of equations, you know this exponent, now it belongs to what we call a base. So the whole goal of this exercise is to get all of these bases to be prime numbers. All right. So with that, let's get into the examples. The first one we've got, 5 to the power of x is equal to 125. Now, at the moment, we can't do anything with the 5 or the 125 because the bases are not the same. And also note, 125 is not a prime base because I can think of several numbers that can fit into 125. So we are going to go about the process of changing these bases so that they become prime bases. Okay. So 5 to the power of x. Let us try and re-express 125 as a prime base. Well, I could say that that is 5 to the power of 3 because 5 times 5 is 25 and 25 times 5 is 125. Okay, so there we go. Now that we have expressed it in prime bases, notice how both sides of the equation have the same base. So as a result, we can simply look at the value of the exponent. So we've got x on the left is equal to 3 on the right. Okay, and if you plug this in, 5 to the power of 3 is 125. So that one is sorted. Okay, next we move on to one that's a bit more complex. Here we've got multiple things going on in the exponents and we have a fraction. So let us start. 5 to the power of x plus 2. Now 25, I know that is not a prime number. So let us change it so that it has maybe base 5. So this will be 1 over 5 to the power of 2 because 5 times 5 is 25. Now the only thing that's standing in my way now is the fact that this is on its own, whereas this is a fraction. So let's go about law 5 where we invert our numerator and denominator. So here, if I want to get rid of this as a denominator, I can carry him and invert him to the top. In doing so, the exponent changes sign. Now look at that. Once again, our bases are the same. So we're essentially just going to work with the exponents. Therefore, x plus 2 is equal to the other side, negative 2. Solving for x, if we carry this plus 2 to the other side of the equation, we've got x is equal to minus 2, which is negative 4. Okay, if you plug it in, your left-hand side will equal your right-hand side. Sorted. Now let's take it up. Alright, this is now more an introduction into the grade 10 level sums. But you can also get it in grade 9 examinations. We've got 27 multiplied by 3 to the x is equal to 1. Now let's see, we need to have prime bases, remember? So 27 we can re-express as 3 to the power of 3. 3 times 3 is 9, times another 3 is 27. Here we've got the 3 to the x. Now how could we possibly express 1 as base 3? Because 1 isn't a prime number. Well, this is law 5 of exponents. 3 to the power of 0 is 1. Remember, anything to the power of 0 is 1. Now that all of our bases are the same, we can simply work with the exponents. So this, first of all, it simplifies to, if I've got the same bases being multiplied, I add the exponents. 3 plus x is equal to 3 to the 0. Now, since the bases are the same, we can say 3 plus x is equal to 0. And then isolating x. 0, this plus 3, we subtract them on the other side. So we've got x is equal to negative 3. Alright, so that one sorted. Now let's deal with the last one. Here we've got 3 multiplied by x to the power of 5 is equal to 96. Notice how the base that we want to focus on is this one here, the x to the power of 5. This 3 is just implying that we are multiplying it. So to isolate this x, I'm going to get rid of this multiplication by 3 through means of division. So I can divide both sides by 3. Then I'm left with x to the power of 5. And the answer to this is 32. Alright, now let's try and do this. X to the power of 5 is equal to 32. What I can do to isolate this is, I can fifth root. Okay, so this is quite an interesting question. To get rid of to the power of 5, we fifth root because these are inverse operations. And what we do to the one side, we're going to do to the other as well. So I'm going to fifth root 32. Well, we've got x on our left-hand side. Now we need to think, what times itself 5 times can equal 32? Well, with our knowledge of prime bases, this would be 2 to the power of 5. So 2 to the power of 5, which is this outer exponent, is equal to 32. So the answer is x is equal to 2. Okay, so we've had a look at 4 examples and understood some of the basic theory. If you have followed through till this point, please drop a like, subscribe, and see you next time.